Hello everyone, it's me Tabo and welcome to another session of Coding for Superheroes. Today I will continue where I left off with my previous devlog. As I'd mentioned previously, the next step in this development phase is creating collisions, and as a result I ended up looking at different options. The first option that I would have liked to go with is Threejs Octree module. I've worked with it before and it's simple enough to apply, but the issue with it is that it has a limited number of collision shapes that one can use. If you look at the module, there are two shapes, a capsule and a sphere. This would be insufficient for this project, so I decided to scrap the module as an option. I remember watching a video from Simon Dev about spatial hash grids, which he applied, I believe, to create an RPG game demo, but the problem with that approach is that it's too complex for me and I don't fully comprehend it enough to implement it in my own game. And looking at the code, it was quite clear that it was going to take a lot longer than I wanted. I initially started this project as something that I wanted to create quickly and later share in tutorial format. After careful consideration, I decided to go off spatial hash grids. My last but not least option is ammojs. I've dabbled in ammojs before, but at the time my knowledge was very limited and I did not fully understand a lot of the concepts. Even basic mathematical concepts like bounding boxes in Threejs eluded me. I've attempted using ammojs for collision detection on my own adventure RPG, but one of the main struggles was to fit the collision shapes, for example, around one of the game objects, or match the rotation of the rigid bodies to my game objects, because some of the transformation data was missing from the meshes after many iterations during level design. I thought of many other ways that I could circumvent this problem. One was to create cube meshes and Blender around the game objects and then import them into Threejs and use the data to generate collision shapes in ammojs, which could have worked in theory, but it was overkill and very inefficient. Now going back to ammojs, I'm more confident that I will be able to better overcome some of my previous stumbling blocks. In this devlog, I will be taking you through all the challenges and victories, so sit and enjoy. Now, considering how far I've come, particularly with the way that I've coded the movement of the player character, I had to figure out how to replicate this behavior in ammojs, and in order to figure that out, I had to come back to this basic example right here. Now, looking at the stage, you've got a cube and a sphere. One is dynamic and one is kinematic. The first challenges that I spotted with the behavior of these two objects is that the dynamic one is being animated with a set linear velocity method, which is basically applying force in a particular direction determined by the player key input. When this happens, then a rolling motion is added as a result, which is not ideal. At the moment, it's not visible since the current dynamic object is a sphere, so let me illustrate by making the cube dynamic also. Yeah, that's not a good look. When I move the tank, I don't want it to be rolling around like a piece of paper in the wind. I could control it by setting the angular factor to 0, but I would still want rotation on the y-axis, which would in turn determine the forward direction. So the next possible solution would be to make it kinematic. Well, so I thought. The problem with that is that kinematic objects don't collide with static objects and they're not influenced by gravity. In my case, that would be okay since the current movements are on the x and z axis, which is basically flat, but I would still need to collide with the walls. But then I thought, what if I wanted to have sloped terrains? Then that would be an issue. It seems like I don't have any other choice. I have to make the player object dynamic. The first major challenge is getting the same movement behavior in ammojs, meaning moving in the forward direction of my character. I looked for ways or similar methods to Threejs like get forward direction, but I found none. This kind of behavior can only be replicated when the object is kinematic. And after numerous hair-pulling attempts, I found myself looking at ammojs examples on GitHub and saw the vehicle example, which kind of displayed the same behavior of my tank. But it was a lot more complicated to set up, which I really did not want since I was just trying to keep things simple. In the end, I could either abandon the idea of having different terrains or go with this approach and embrace the hellish path that awaited me. First things first, my tank has no wheels, so I jumped into Blender, added wheels to my tank and then imported it as an OBJ. This whole process simplified would be to have a chassis which would make up the vehicle, then 4 wheels which would be added to the vehicle with a number of settings and values. Sounds simple enough, right? Yeah. My first few attempts were a bit frustrating to say the least, because when a group of meshes are imported as an OBJ, the transform values are zeroed out and set to origin, which then creates a weird behavior when the vehicles are constructed. Any rotation made to the meshes should be quaternion and not Euler. Make sure that each object pivot is set to center of mass, and last but not least, clear rotations before importing to avoid problems. Finally, after a few adjustments, I got something that works. It looks a little something like this. Now I'm fully aware that no tank looks like this, with wheels hanging off the side, but it works, and from the main camera perspective, it's all good. Since I kind of had to change the code to fit the production pipeline, I had to do some projectile tests once more. These giant red balls are projectiles and they seem to be following the right trajectory. Okay, now let's take this baby to its home ground. Next I will import the level assets and assign them their respective rigid bodies, then test for collisions. Okay, after all that hustle and bustle, finally I've got something that works. There's still a lot that awaits me, but I'm glad to have arrived at this point. And thanks for tagging along, it's been a pleasure having you. If you have not yet subscribed, please do press that like button, hit the notification bell, and join me on the next episode. And with all that said, I will leave you by saying love and peace. I'm out.